All right, so I want to welcome you all here. Can you please let me know if you can hear me properly? Just you can say yes, or even you can use the chat box. Okay, perfect. All right, so it is quite exciting to see people from such a diverse background, and I am very positive that this is going to be a very interesting learning journey for all of us. Okay. Okay, just give me a second. My voice is a bit low. Okay, how is my voice now? Is it better? Sorry. Okay, so again, let me welcome you all in our first session of this course, Calculus Connects. And of course, since you have joined this course, like the expectations and the content we are going to have now. Just give me a second. Just give me a second. Let me adjust the slides. Just give me a second. Sorry. Okay, so let's get started again. So first of all, this course, I can say that this is going to be a bit different one than like you might have seen in the universities and schools. It is because basically the idea is that when we learn calculus, actually the easiest part of calculus is calculus itself. Like why many students find it very difficult. It is because of the algebra and the calculations which is involved. So our task actually is to learn the calculus without getting lost in the algebra and other calculations. And to achieve this goal, or to achieve this aim, we are going to learn some technology or some educational tools. The first one actually we will be using is the GeoGebra, and there are some more. For example, Desmos we have, and we have also Wolfram, Cloud, or Mathematica. But personally, I think the Mathematica is going to be a bit more advanced. So we are going to mainly focus on the GeoGebra app, and in this course we are going to discuss also how we can learn them, the interface, and how we can leverage this the power of GeoGebra to avoid as much as we can the part of algebra and focus mainly on calculus. So it's more like a concept based and technology centered. So I hope this is going to help you both if you're a student and even if you're a teacher. So you can use this tool because, as you know, in the 21st century, we have all these tools available. So many of the external examination board, especially IB, since I'm also IB examiner, in IB it's like a Cambridge A-levels system, but they focus actually mainly on this use of technology. And also in coming days, Cambridge, and even in Pakistan, our board, the single national curriculum, they are changing. So they're also planning to integrate technology as much as we can. So this is actually the need of the time. So I think it's a good time for all of us to focus and get help from this technology to understand apparently this difficult subject. So I hope after using this technology, the calculus won't be clueless. So we will find a clue and we will focus on the very idea of the concept in calculus. All right, so first thing first, let me tell you about myself. You might have seen, you might have actually read the introductory part on the email sent to you. But actually, I'm, as you know, my name is Hassan, and I worked over 7 to 8 years in different settings. So I was IB examiner, But these days I am working in Cambridge school. But I also have experience, I did FSC, for example, so I'm very much aware of the local system, and also the Cambridge system, and also the IB. But again, the task is not actually to prepare you for the exam or for the Cambridge exam or for IB exam, but the aim for this course is to mainly focus on the idea or the concept behind calculus, and finding the clues of the calculus and see what it is. Yeah. By the way, if you can always send me a text message, during the presentation. So I will be, I would love to actually hear from you. So if you need any clarification or anything, please do ask. Another thing is that, I'm going to make this session and all the sessions more interactive, or the student center. So that means, like now we have 90 minutes. So it is not me who is going to talk throughout the time, but I have also prepared some things. For example, we are going to use GeoGebra, and I will also assign you some tasks. You will be doing it there. And also some other quizzes, I have prepared for you to understand, to see how things work. All right. So first thing first, before we start working on this, calculus course, just remember, the difficult part of math, while you're doing mathematics, and sometimes, we get stuck and we feel, unfortunately, that it is the difficult subject. But that is not the case, actually. It's not the difficult, math is not the difficult part. And, our motivation, our understanding, and that is the main thing. So like once you understand the very idea of mathematics, I can say from my experience, it is impossible to not like mathematics. It is such a powerful thing. So once you understand mathematics itself, so this becomes the most, enjoyable thing in your life. So basically, let's try to see what exactly math is. Why we find math so difficult. So actually, so let's discuss about what math is. Like generally when we think of math, we think of calculations and like working and this and that. But what exactly is the mathematics? Can you basically tell me? If you want to unmute yourself, you can do so, or you can also use the chat box. Sorry. So what do you think? What do you think the math is? Like math is, what is math? For example, like when we talk about physics or chemistry or history, it is quite clear. Like in history, we study about the events happened earlier in the earlier times. In chemistry, we study about the chemicals. In English language, we learn about the language. In the social sciences, we learn about the social issues and things. So what do we study in mathematics? What is the essence or the core principle in mathematics? Okay, we have got Muhammad bin Tariq. Okay, so Muhammad.
Sir, I think maths is problem solving.
Math is problem solving. Okay, perfect. Thank you, Muhammad, for your answer. Yeah, but the thing is that, problem solving, we also solve problems in other subjects, right? This is, of course, this is very true. Math is problem solving, but what makes math different than other subjects? In physics, we also solve problems. Even in business, we also solve case studies. We do case studies, we solve problems. So what is the speciality of mathematics? And again, why math is so important? For example, like, once you go to the universities, the entrance exam is always based on mathematics. So what is so special about math? Why they emphasize so much on mathematics? So perfect. That is the right answer, but there could be more answer. So Mr. Abdullah, yeah, you can tell. Yeah, Abdullah.
It can also be a way to manipulate numeric quantities. That can be a basic definition.
Yeah, nice. All right. So basically, Abdullah just said that, when in mathematics we manipulate numerical things. So that means we solve equations and we find the answers. So this is also mathematics, but that is actually, to be honest, this is part of the mathematics, and we call them calculations or arithmetic. So the math is actually beyond, it surpasses all these things. Like when we solve the equations, we solve the value of x and things. This is actually called the arithmetic, for example, or the calculations, right? So this is not the whole mathematics. Of course, this is part of the mathematics. What So what exactly is the mathematics? Let's try to even broaden our understanding. So these are actually quite nice idea. So I want maybe other people to join to discuss what math is. So
Hassan, there are quite a lot of answers in the chat box. Do you want me to read them out for you, or you can do that?
Actually, I can read, but let me just wait a second. Okay, maybe you read them first, some of them, because I want to. Yeah, please.
It's okay, I can do that. So Asif Kamran says that's a way of presenting everyday problems in form of equations and relationships. There's Elif Iskander who says that mathematics is the language of the universe. Then there's Raza who says that the study of numbers and its applications. Waqas Tariq says that maths means measuring accuracy in daily life. Math is a tool. Then we have another question that that finding and predicting the unknown. That's what Shayan says. Manu says that it's calculations, patterns, and everything in between. Wakar says that math is a tool to solve different problems. And Nadia, this is the last one, dealing with shapes and quantities.
All right. Yeah. Thank you. Thank you very much. So that means, we all have, we have a very nice participants who are actively involved. And of course, all your answers are quite, they're correct. There's no wrong answer. But, generally, all these answers, what we understand actually is mostly, when we think of mathematics, we think of calculations actually. When we basically, in our system, we are asked to, for example, to solve the quadratic equations and find the area under the curve, find the derivative, and find the angle of the trigonometric functions. So this is also part of the mathematics, but this is actually not the full mathematics. So actually, of course, you have the right to disagree with me, but honestly, math is more about ideas and finding the connections between ideas. And we will see actually why is that so. Also in this course, you will see why math actually, these calculations, this is actually maybe 10% of the whole mathematics. But the main thing about the mathematics is about ideas and finding connections or patterns between those ideas. Okay. So let's do some brainstorming. Until now, we have learned actually lots of topics in mathematics. For example, we have learned the quadratic equations, polynomials, system of linear equations. But actually, if you allow me, we can actually categorize all those concepts into actually 4 different categories. The first one is algebra. The second one is geometry. The third one is probability and stat. And the fourth one is calculus. Actually, until now you have whatever you have learned, or maybe if you're in grade 9 students, then maybe you haven't seen calculus until now, but you have seen algebra, geometry, and probability. And everything else, actually, whatever comes in your mind, we can actually put under these categories. For example, equations, how to solve the equations, we can put into the like algebra. Here we find about equations and so on. Then we have the geometry, and this is actually in geometry. So maybe can someone tell me what have we studied in geometry? What are the topics we study in geometry? Shapes and angles, perfect. And also like the trigonometry, the sine, cosine, and tangent, because they're also about shapes and so on. So as you can see here, so we can categorize them into 4 different categories. Okay, so since these are algebra, geometry, and probability, these are like very technical terms, we also want to simplify them. Again, because math is all about ideas and finding the simple answers. So let's think of if we want to, maybe let's start with the geometry, because I think it's a bit easy. When we study the geometry, the geometry is the mathematics of, if you allow me to say, I can represent this with only single word. It's actually the mathematics of shape or shapes, right? Actually, I got one answer from MRK. I don't know who is this, but shapes and angles. So actually, the geometry is all about shapes. In our universe, all the physical things, they have some shapes, right? For example, planets, they are spherical, or the shadow of the building, they also make the triangle if you find the base and things and the height. So everything else, even human body, our heart, our table, everything is all about shapes. So it's important to understand them, to find those connections. So when we study shapes in geometry, what about algebra? What do we study in algebra? Like, what is algebra? You know, in algebra we solve equations, right? And for example, like generally we use algebra to solve equations, but what exactly it is about? Yeah, so we have Khwarizmi. Actually, I would recommend you to use your, like, if you are logging in, if you use your own like original name, it would be easy for you, for me to pronounce your name. So I have something Khujista. So
That is their
actually,
original name. I'm sorry. Khwarizmi.
sorry,
Yeah, that is their original
Khwarizmi.
name.
Oh, I'm very sorry. It's very interesting name, by the way. Khwarizmi. I'm sorry. I'm sorry, Khwarizmi. Is it a Persian name or what? Or because Khwarizmi? Turkish. Khwarizmi. All right. Nice. I think it's Kurdish, not Turkish, because in Turkish there is no khe. There is no KH there. Okay, no worries. So algebra is about unknowns. So we actually study about unknowns, but what actually algebra does to unknowns? It's not actually, we find actually unknowns in algebra, but in also in geometry, we also find the unknowns. For example, we also find the angles and things. So what exactly we do actually in algebra? It's a bit tricky thing, but let me still write here. We have got one answer. Algebra is about making connections using unknowns. Actually, yeah, it's quite close. Hamza, it's about connections, finding the connections. Or actually, if you allow me again, one word, it is about structure, finding the structure between the unknowns. So when we say structure, that means, for example, can you give, for example, like there's very, very important equations, which you all know, a squared plus b squared equals c squared. So by the way, you all know this is the Pythagoras. So we all know a and b, a, b and c. So this is a and this is b and this is c. So what algebra actually does us or tells us, it finds a connection between them. So how the a and b and c are connected in a triangle. And of course, once you make a connection, then of course you solve it. And of course, algebra or arithmetic or the calculation helps you find the unknown. But the main thing actually algebra is used for is to find the structure between the variables or the unknowns. And again, so as Elaf is saying, it deals with equations, inequalities, and trigonometry. So of course, we use algebra because we want to find the structure, or when you say structure, actually, this also means connections, as Hamza suggested in the chat box. So structure also means the connections, yeah? Connections between the unknowns or variables. Okay, so now we have got this algebra is about structure, then we have shapes, geometry is about shapes, then we have the probability and statistics. So can you come up with a single word to define the whole probability in statistics?
John.
Analysis of numerical data. Okay, Adnan. Okay, so maybe, of course, this is not right about likelihood. Okay, so we have a lot of answers, estimation of reality and so on. Actually, we got one answer from Muhammad bin Tariq. Is chance, exactly. So structure, shapes, then we have a chance. So, and this might be quite interesting. How come a chance? Chance is actually like a very everyday word. I mean, generally, when you think of chance, you don't think of mathematics, because math is certain, and math tells you the answer and this is what we have been told. Math is all about the certain and all this. Common day word is such an important tool, or this also shows you the power of mathematics, right? So the math is also connect the chance, all these things to it also gives you a formula or formulations. Actually, I want to talk about chance a bit more, but let me not do it. Maybe in some other session we might discuss about, because it's a huge topic, by the way. So the chance is important in our life. By the way, the electrons density or the motion of the electrons is all about chance. If you have done the chemistry, this s orbitals, p orbitals, and so on. Those are actually the chance of the electrons or the particles to be at that position at the particular time. So it's all about chances, even the position of the electrons. And since the electrons and the fundamental particles, they are building blocks of everything. So it's important to understand how they behave. So the probability comes in there also to understand the reality or what is happening. Okay, let me stop here about chance. Let's move on to our main topic. Then we have calculus. Yes. So what is calculus about? And that is very, very important, because from here we are going to start our journey to, okay, sorry. Am I clear now? Can you hear my voice? Okay, perfect. All right. We are getting a lot of answers. Small numbers, study of change in function. Yes. Okay. All right. So some more ideas. So what is calculus about? Maybe in one word, limits. Okay. Or what do we study in calculus? Maybe if you have ever seen calculus in your course, you can also write those words maybe. So we want to come up with maybe a single word which can define the whole calculus. Of course, this is not going to define completely, but we want to get an analogy. This is how we should learn any subject. Study of functions, rate of change, areas of curve, change, integrations, study of continuous change. All right, so we are getting a lot of answers, and I'm quite excited to see that most of the answers are quite. I mean, all of the answers are okay. I mean, they are not wrong. There are no wrong answers, by the way. So if you allow me to write calculus in one word, it is going to be actually what? It's going to be change. Okay, now we know, of course, as I see in the chat box, there are so many answers about change. So perfect. Let me pause for a while here, and let me ask you, why do you think calculus is also like the most important thing? Not the most important, but one of the most important subject in mathematics. And by the way, once you go to the university, in your first year, the first course in general you take in mathematics is about calculus. So that is the building block of actually most of the research work in engineering, in sciences, even in medical, in medicine, in economics, in business. So what is so important thing about change? Why change is so important? It has the most applications. Yeah, that is the question. Why calculus has the most applications? What is the reason? Evaluation of system. So we can predict solution to large value numericals. Yes, exactly. So these are actually quite technical terms. Yeah, that's very nice. My question actually, why change is so important? What I'm expecting from you is to give me the answer in a layman terms. Like, for example, if you ask a grade 5 or 6 students about change. So what would be his response? So not in the term of mathematics, but more like in a generic term. Okay, we got one answer from Waqas Tariq that he's saying because in real life, almost everything phenomena is changing all the time. Do you agree, by the way? So Tariq is saying that, or Waqas is saying that, almost everything is changing all the time. Do you agree? Because change happens every second. Actually, yes. Yeah.
There are some constants which will never change. For example, the speed of light.
Okay, speed of light. Okay, very interesting example. But yeah, speed of light does not change, but everything else maybe change. You are saying. Actually, yeah. There's only one constant in the universe. By the way, it's not the speed of light. Speed of light is a constant. Actually, it tells you, like nothing can go more than the speed of light. Basically, this is the statement. But there's actually only one constant in the universe, which is the change itself. So you might have heard this quotation that change is the only constant. Actually, let me write here. Change is the only constant in the universe. Actually, this is a quotation by Newton. This also signifies that change is everywhere. Change is the only thing which is constant. That means everything else is changing, but change is always there. So, since the universe is evolving, as you have seen, also, if you want to think, understand why it is, everything is changing, because everything also depends on time. And since time is also, moving, so everything has to change. So that means, to understand the universe and how it works, it is very, very important to understand the very idea of change. Okay. So that is why the calculus is, this is actually the thing. Like until now, you have learned algebra, geometry, and probability, and this might actually seems a bit boring subject, because this of course tells you, it also connects you to the real world. But the calculus, the way the calculus connects the mathematics to the real world, I don't think the algebra or the geometry or the probability can connect. The reason again is the same, because the calculus is all about change. And since we are so much accustomed to change in our daily life, so this is actually, the calculus is going to help you to really understand mathematics. You might have seen, actually, you might have heard that the math, math is important to understand the universe. But you might have wondered the whole life, like generally, honestly, we don't use mathematics, especially algebra, in daily life. For example, if you have you ever if you remember, when did you use last time quadratic equations or parabola in daily life? I don't think so. That maybe 1% of the people, they somehow they use in their daily life, but that is not the case actually. Also the geometry, the trigonometry, and sine to sine, tangent theta, or all these things. Even the Pythagoras theorem, which is very, very famous, we don't generally use in daily life. The reason again is because the calculus actually is the key subject, which is really going to tell you how things works in daily life, because it's all about change. Okay, so I think now you get the idea of what calculus is and what we are going to study in this case. As I told you, I should not be the one who is speaking the whole time, so I will avoid this thing. But since this is the first session, I have to take the lead, and I have to make some connections. So from here, actually, from this slide, let me just tell you a couple of things. We are going to learn about GeoGebra also, because in our first slide, you have seen that the calculus is the easiest part, by the way, in the calculus. The difficult things are the algebra and the calculations. So I will try to discuss the GeoGebra tool, or there are some other technology, and we will try to do most of our algebra using that software or the applications. Okay, so we can focus mainly on calculus. Okay, so this is actually our main target for this one. Okay, yeah, I think right now let's not discuss those philosophical things, for example, invented or discovered. But I really appreciate you, Raza Khan, for your question. Actually, I love the question, so please keep asking questions. I might skip them, or maybe we will do these questions during the whole week. I will try to maybe see if we can make a group or something somewhere, so we can discuss all these things, by the way. So but this is important to ask question. Whatever comes in your mind, do ask. There's no wrong questions, or there's no silly questions. Okay, so please do so. But let me not discuss these things right now. Let's focus on calculus, the change. Yeah, again, the reason, because we have a limited time, we have only 5 sessions, and we have to cover a lot of things. So we will touch the whole calculus. Of course, we'll study their core concept in calculus, and avoiding the algebra. But let me be very, very clear here, that I'm not in any way saying that algebra is not important, or you should not study algebra, just study calculus. No, this is not the case. You have to study algebra because you have to. There's no way out. But in this course, we are going to focus mainly on calculus. Okay, so don't take me wrong that I'm discouraging to learn algebra. You have to learn algebra, and you should learning the algebra. Actually, is calculus really more useful in real world? Yes, actually, useful in a sense, because calculus is all about change, and everything is changing. Actually, I'm going to create a breakout room, and I will ask you to, since we have learned that calculus is all about change, so you have to look around in your surrounding and find out what are the things which are changing. For example, let me just give you some example. For example, the wind, or the wind current, the air current. When the wind comes, because of high pressure and low pressure, this is how the we have wind or the air current. So it means it is changing. So if you want to understand their how they work, or how, like if you want to predict their behavior, we have to learn calculus. For example, height of the tree, depending on the height of the tree depends on the sunlight or the soil or the water. So if we have all these parameters, how the height is going to increase depending on the time. So even the height of the tree, we can also make a mathematical model. For that, we have to use calculus. In chemistry, we have to study about the rate of reactions and so on. So basically, every single thing you just name it, it depends on some. It depends on time. So it is changing, it is evolving. Even the shape of the universe itself, how the universe is expanding. So if you want to understand them, you have to understand the calculus. The motion of the planets, for example, motion of the electrons. Actually, also in statistics, while you study the distributions, normal distribution, binomial distribution, they also comes from the statistics, all these things. Okay, so I will come back to this topic change in a while, after 10 minutes. And then we will also quantify, since calculus is all about change, it's the mathematics of change. So how can we quantify change? So our next target, our next goal is for today's session, is to quantify the change. So when I say the quantify, we have understood the change qualitatively, we understood them, what is the meaning of change and why they are important. So our next task is to quantify them, okay, to make a formula, mathematical formula out of change. And then we will build all those things, which we study in calculus, derivative, integrals, limits, everything, but it has to be based on change. So change is our key term throughout this session. We move on. Just to give you a more idea, as we discussed, calculus is all about change, and change is the only constant. As you can see here, we have one example. If you see these circles, 2 pi r and pi r squared, this is the area of the circle. Then we have 4 pi r squared, which is the which is what? 4 pi r squared is the surface area of the circle, and 4 over 3 pi r cube is the volume of the circle. As you can see here, these equations, 2 pi r squared, and 4 pi r squared, and 3 pi r squared, they have some, like, they are connected apparently, right? So there is some kind of connections, even there is a symmetry, not symmetry, but there is some kind of connections. So basically, this is all about the change. For example, like area is the, if you change the circumference from the top to the center, we get the area. So calculus is going to help us also derive these equations. I think until now you have simply found these equations and you just have memorized them. But I think this is the time to learn how this is derived. So we are going to derive, but not now, not today's session, but in the session when we're going to study integrals. Okay, so I'm just giving you some examples, the power of calculus. So all those formulas which we have seen and which we just took for granted, and we simply use them and never worried about their origin. So the calculus will give us a chance or an opportunity to also understand those equations. Okay, so let's also discuss this thing very quickly, what exactly it means. I'm going to show you like a quick slide with some explanation, and then you will see why the area of the circle is pi r squared. Okay, let me see if I can find it right now. Just give me a second. Yep. All right. So are you with me? Let's have a look at these slides and we'll see what it means. Okay. So if you have a circle, and if you draw as many rings inside as we can, and then if you simply unroll the rings and then line up them like this, yeah. Just have a look here. So this will become like a triangle, if you can see. But if you put more rings, for example, and if you make the lines skinnier, then elegant. So, if you continue, and then we'll get a nice triangle. And so we can simply find out the, the area of this triangle. So as you can see here, this side is going to be the radius of the circle, like from the previous circle. So this is the radius. And this side is going to be the circumference, right? 2 pi r. So you know that the formula for the triangle, the area of the triangle is half times base into height. So we can simply replace those guys. So area is, the base is r and the height is 2 pi r. And if you simplify them, we get the area of the triangle is pi r squared, and that is the area of the circle. Okay. So as you can see here, like we will use this very idea of taking things in a small chunks, and we will find out the equations, all these things. Okay, is that? Okay, so we have learned, in the future we will also see how the surface area of the circle is 4 pi r squared, and the volume of the sphere is 4/3 pi r cube. But we have to wait for maybe 2 more sessions. When we study the integrals, then this all will make sense, and these formulas and also more formulas. Okay, let's continue our first topic, which is about limits. But we will discuss them. First of all, let's have a look. Since calculus is math of change, and this answers quite impossible questions, which apparently is quite impossible to answer. For example, when can rectangles measure a curve? This question might seem quite irrelevant for you right now, but you will see that once we learn the integrations, you will see this is going to really help us. For example, like when can rectangles measure a curve? Like a circle. Actually, if you zoom in a circle, it's essentially like it has infinitely many corners, or it can be made with the with the polygons of infinite sides. So we will see like how the calculus help us to make life smooth, and find the area under the curve and so on. So this is the topic of the integration, which we're going to learn. The second question is how can we detect instantaneous change? So this is also a very important thing. The word instantaneous, it means at the particular instant, at a particular time. So for example, like when we study about the speed, for example, the speed is quite common example. The speed is given as the distance over time, right? Or the change in the distance over time. So the distance over time. So this is the formula which you have seen, I think, so many times. But when we say the word instantaneous, this actually creates a very serious problem, because to find to find a speed, we have to measure the distance between 2 points, and we have to find the time between those 2 points, and then we can find the speed. But then how can we find the speed at particular instant? When we're talking about a particular instant, that means the distance between, there is no distance covered in that particular instant, right? I mean, apparently, seemingly. So to find the speed, we need to have 2 points in space, and we need to find the distance between those 2 points. So the calculus is also going to help us. This is actually the topic of the derivative. So how it can help us to understand the idea of instantaneous change. All right. Otherwise, if you don't study the derivative, we will not be able to answer, and we will not be able to find the speed of, let's say, of your car at a particular instant, because we can only find the speed between 2 different points in the space. Okay. So we will see this thing in the next session. The next session is all about derivative. So we will focus more on these things. Yeah. Okay, so as we have learned in the previous slide, that the calculus is all about the mathematics of change, right? So how can we quantify the change? So our target is to now quantify the change. So does anyone do you remember have you ever studied how to like the mathematics of change? And don't tell me the answer from the calculus, because this is, I mean, we are going to build the concept of calculus. So from, let's say from the elementary school mathematics, have you ever studied the mathematics of change? Or is there any terminology in mathematics which quantify the change? Yes? Difference?
We can think of it as a shift from one set position to another over a particular defined amount of time.
Okay, so what is that thing called? Like, I'm just asking, like from, let's say from grade 1 to grade 8, what is the mathematical terminology or the concept we used to quantify the word change? So of course, we can find change by doing something, but actually there's something which you have studied. Actually, I think even from grade 5 or grade 6, we study these things actually. There's a terminology which we use to measure the change in something. So let's see if you percent is also, yeah, okay, nice. It's also like it tells you how much something is changing. But actually we have got actually an interesting answer from Waqar Azim. He's saying gradient or the subtraction or the rate. Yeah. So the rate and the percentage, actually percentage, it tells you how much something has changed. But the gradient itself, the word gradient, actually that's the right word. Gradient itself means the change, how something is changing. So essentially, the calculus we have already studied, from grade 5 when we were finding the gradient or the slope. Actually, the second word for the gradient or the easy word is the slope, right? And you have seen also these questions from the quizzes. So we have already know how to quantify the change, right? So if that is the case, then what is the need of, sorry, wait a second. All right. Yeah. So basically, the gradient or the slope, we use the word m generally for the slope, and we know this is change in y over change in x. So we all know this idea. So this very good thing basically. So we will build our concept of calculus from this very concept of gradient. All right. So let's very quickly discuss this gradient, slope or gradient. So we know this change in y or change in x. Okay. So how can we fix this equation? Like what is, like if the calculus is all about change and we already know how to find a change. So what is the point of learning calculus? Like that means there is a problem with this expression. So when we have the gradient here or the slope, this equals, I can also write this as change in y, delta y over delta x. So this delta or this triangle, this means change, right? So do you see this? Do you see any problem with this equation? Like there's actually a very interesting problem with this expression, and we want to fix that problem. Yeah, it requires two different points. Okay, so I mean the change has to require two different points, right? Because if there's only one point, then it is not possible to find a change, apparently, right? So how can we find? How can we improve this thing? So Mr. Shayan wants to say something.
Yes,
Shayan.
the change is not continuous at every point. The change is always different.
Okay, nice, Shayan. So Shayan actually is trying to make a point that, when you find the gradient, by the way, the slope or the gradient, we can find the slope of a function, right? So what is the name of that function which we can find the slope of? For example, like, we have a linear function. Let me show you actually here. On this slide, you see that there are 6 different functions. But the thing is that, the first function, this is called a linear function, and the slope is only defined for this function. The reason is that, the slope is, we know the formula is this for the slope, m equals y2 minus y1 over x2 minus x1, which was a change over y, change in y2, change in x. But that is only defined for the linear equation. If we define the same thing for the other equations, let's say for quadratic, then this will not work, right? If we have these 2 points, then the slope, the value of the slope will be different than if we take these 2 points, for example. So the value will differ significantly. So we have to improve this point, and to improve this point, actually, I have seen some of the answers that we have to make the difference quite small. What actually I mean here, let me just go back to this slide. To understand, to improve this slide, I want actually this to make, sorry, is that? I want this, I want this delta x to be extremely small. So I will improve this slope, I will call it some other name. I will just discuss with you right in a while. So I will say still delta y or delta x. But to improve this thing, I will say that delta x is extremely small. Okay, so delta x is extremely small. Okay, so now actually the problem is that instead of writing delta x is extremely small, there is a very nice or interesting notation. Okay, so instead of saying that delta x is extremely small, let's call it. Let me raise this thing. Let me instead. Instead, let me simply use the word limit. So this is a fancy word, limit, and limit actually means like we want to limit the change in x. So let's say the limit delta x is extremely small. So that means it goes to 0. So change in x goes to 0. So that's how we can improve the very idea of slope. So when we say delta x, delta y or delta x, same thing as slope, but when delta x is extremely small, and by the way, when you make delta x extremely small, delta y automatically would become smaller. Okay, so we call this guy basically, we call this guy as, instead of writing this whole thing, limit delta x goes to 0 or delta y or delta x is quite it's quite lengthy. So there's actually a very nice word. We can write this as dy over dx. So this is how we define, and this guy actually, we pronounce as dy or dx, and this is called derivative. Okay, but of course, we will study about the derivative in the next session. Today we are going to focus on the idea of limit. Okay, so that means the calculus, we will start from the limit, and then we will build the idea of derivative, and then we will go move on to integration. Yeah, so we can use derivative to measure slope of any line. Perfect. So the derivative, the origination of derivative comes from the very idea of limit. So it's time for us to maybe to discuss limit a bit, because this is going to be important for our next concept. Okay, so as you can see, we are going to build the idea of calculus step by step. Okay, so the very first idea of the calculus is the limit. So what exactly the limit is? So let me discuss a couple of things before we move on to GeoGebra. Just give me a second. Yeah, let me discuss these things first of all. So we have actually 3 main ideas in calculus. So these are called the core concept in calculus. For example, because the calculus is all about change. So to understand change graphically, we can simply make a curve, let's say, and let's make a curve. Let me use a blue color. Sorry. Yeah. So let's say if you have this curve, okay. So basically, from this curve, this actually tells us how things are changing. So as you can see here, let's say this is time, and this is some function. So when the time was 0, the value of the curve was, let's say it was at some point. So it is 1, 2, 3, and 4, and 5, and 6. So at time 0, the value of the function was 4, for example. As the time was increasing, the curve was also increasing up, and then after some point it becomes it starts decreasing again and then increasing again. Yeah, so this is actually like a very simple model of a change. Okay, so let's try to see if this is change, how we can understand the calculus from this curve. Okay, So in the calculus, we are going to study, first of all, like from this curve. So we are also interested in to know the value of the curve at particular point. So for example, what is the value of the curve? Just that. I'm sorry. Yeah, there's the value of the curve at this point, for example. At this point, yeah. So at this point, we can simply see the value of the curve from, like, we can read from the y-axis. So this looks quite simple, like to find the value of a particular point from the curve. But sometimes, in mathematics, we also have black holes or loopholes. So sometimes, the value is not particularly defined on the y-axis. So we will see how the limit is going to help us. So to find the point, actually, this is actually in mathematics we call them, or in calculus we call them limit. So we will see why are they important. Second thing is that if you this is a curve, and we are also interested in knowing how the curve is changing. So for example, how it is when it is increasing or when it is decreasing and so on. And this is important because let's say if this curve is about the profit of a business you are doing. So you want to know like in which interval of time you are making a profit or you are losing, right? So you have to understand all these things. So the change or it's also called the slope. We can call them actually slope. It is given by derivative. The last thing which we are interested in finding from this curve is the area under this curve. And we will see actually when we study about the calculus integration, why the area is important and what it signifies. So the area actually, it is given by integration. Perfect. So we have three things: limits, derivative, and integration, and we can all see it from the one single graph. So our session actually, we have 5 sessions. We are going to focus on limit, derivative, and integration. So the plan is that today we are going to mainly focus on limit. In the next session, we are going to focus on derivative. Then in the third lesson, we are going to focus on integration. And in the last 2 sessions, we are going to understand their applications. And we will be using lots of different softwares and technology to do these calculations. Okay. All right, so you understand the idea. We will solve some questions from the limit on GeoGebra right now. So for that, I would like you to go to GeoGebra. I'm going to change my screen. Let me see. Wait a second, yeah. Okay, so let me change my screen right now. Okay, so what I want you to do right now is to you see my screen, right? So if you go to this website, geogebra.org, so let me also share the link with you. Chat. Okay, how many of you have basically used this tool, GeoGebra? Let me see if I can create it here. Okay, nice. Nadia, okay, perfect. Okay, so I mean, if you have used it, it's perfectly fine. If you haven't, so if you go to the geogebra.org, you will see this kind of home page. And if you simply click on Start Calculator, you will see this page. Okay. I also want to actually to create your account, because as I told you, we are going to use GeoGebra a lot. We will do most of our calculations on GeoGebra. So you have to understand this quite well. We will also be using some other softwares, let's say Mathematica, but Mathematica is paid version. So we can also use Wolfram Cloud, which is free version of Mathematica. So we will also see, but first we will focus on GeoGebra. It's very powerful, basically. And so let me give you a quick introduction to this interface, maybe for the ones who are using it for the first time. But soon you will see we are going to do some quite advanced calculations on this one. It is like Desmos. Yeah, it is like Desmos exactly. Yes, but of course Desmos has its own limitations, and GeoGebra also has its own limitations. But if you have used Desmos, then it will also be okay for you. Okay. So the idea is that we are going to do our calculations on GeoGebra. Okay. I will also be going to assign you a lots of questions maybe throughout the week on this tool. Okay, so you see this. So do you all have this screen, or maybe don't go to the screen right now? Let me give you a quick demo or introduction to this interface. So as you can see here, if you go to this the calculator page, so there are actually graphing calculator, 3D calculator, and geometry and CAS. CAS is about computer algebra system. So we will be using CAS and the graphing one, but make sure that you are on the graphing app of this GeoGebra. Okay. So graphing means once we do the calculation on the left hand side, you will also see the graph on the right hand side. So this is very fun because we can see what is happening in real time, like how the graph is changing. So let me just show you a couple of things. So first thing first, let's find 2 plus 2. So if you simply type here 2 plus 2, this will give you the answer directly. So we can simply do the basic arithmetic. Okay. We can also plot the graph sin x. So sin x, we see the graph here, and for example, tan x. So if you simply press enter, and if you type tan x, you see the graph of tan x. Let me make one more graph of the cubic equation. So 2x to the power 3 plus 4x squared minus 3. Sorry. Okay, so now basically you see we have 3 graphs, right? We have sin x and tan x and h on this cubic equation. So a couple of things I just want to show you. For example, if you click on this green radio button, you can turn the graph on and off. So you can toggle the graph on and off from clicking on this. Okay, basic ones. So you must understand. You must know how to use this tool to do the simple calculation. Okay. And basically, once you plot this graph, you see there are these points. If you click on this one, it will also give you these values. So these are the roots of the thing. All right. So this is the thing. This is actually, and if you go on to this thing, it's called the tools or the shapes or the construction tab. So you see there are a lot of extra tools, like move. So if you click on the move, and you should be able to move this. No, because this is defined with the formula, so you will not be able to move. You can find out the angle between 2 sides. You can find out the parallel lines and tangent lines and so on. So let's say if you click on the tangent, then you also read on from the help. It says, let me click again. Select point or line, then circle, conic, or function. So for example, if I click tangent, and if you click any point here, and then sorry, what is that? I need to make a point first. So I can also, if you go here, we can also make points on GeoGebra, and then you should be able to find the tangent. So you see, it gives you the tangent at on the curve. So we will explore them in detail when we do the derivative and so on. So right now, actually, what I want to do is to do some calculations on limit. But before we do so, let me just simply show you one thing here. If you go to this keyboard, you might see this keyboard, right? By the way, this app also has the mobile Android and iOS applications. So you can also install on your Android phones. You can also use it for the exams because it also has exam mode, which disables most of the operations. Okay, so if you click on these 3 dots, basically, you see there's all the functions and the things which you can do. So geometry, algebra, text, logic, functions and calculus, conics, list, vectors and matrix, transformation, and so on. So as you can see, this is quite powerful. Even if I think it's more powerful than most of the calculators, even the graphing calculators. So it's a good idea to use GeoGebra, and also maybe in the exam also you should be able to use with your phones. In the exam mode, there are some options in GeoGebra. So if you click on functions and calculus, so you have all these options for the finding the integrals and finding the derivative and finding the curve and derivative, extremum, the extreme points. So that means we are going to explore most of these functions, and we will be using these things instead of solving them using the algebra. Okay. So first thing, let's find the limit of a function. So let's try to find the limit of some particular function from this. Yeah. So let's say we have a function. So I will simply type limit, and then in the bracket, I will first type the function, and then I will write down the point at which I want to find the limit of that function. So for example, if I have sine x, and if we want to find the limit at 0.0, so it gives us the answer as 0. Okay. So this was a very simple example. Let's find out first. Let's first define the function as sine x over x. Okay. So you see this function. And by the way, if you want to zoom in and zoom out, you can also use. You can, if you're using the touch screen, you can simply use your fingers, or otherwise you can simply use the mouse pad to zoom in and zoom out. So as you can see here, this is the function f of x, which is defined as sine x over x, and this is actually quite famous function. And let's find the limit at the point when the function is 0. Okay. So for this, what I will simply do, I will simply type here limit, and then the bracket. So I have to write the function first. By the way, if you simply type here limit here, as you can see here in the drop down menu, automatically it gives you some hint. So it says limit, then the function, and then the value. Okay. So let's type the function first. But since we have already defined the function, this is the function of f of x, I can simply type here f only. Okay. It will automatically take f from the previous cell. And then I want to find the value of f at 0. And as you can see here, it is 1. So the idea of limit, we can find the values of limit from here. So I think you get the idea. But actually, I'm going to share some questions with you. I want you to try this question. For this, I have to change the screen. Let me do it again. So here we are. Yeah. So I have some question for you. I want you to try this question on Desmos app right now and see what is the limit, the value of the function x plus 5 whole squared minus 25 over x when x equals 0. And we will also see the application, like why this is important. But first, I want you to try the GeoGebra app and to solve this kind of question. So let me give you maybe, let's say, 3 minutes, and let's try maybe the question number 21. This question only. Okay, x squared minus 9 over x minus 3 when x is 3. So just try, and then I will also show you how to do it on Desmos. So if you have a piece of paper, I want you to copy this thing so that I might need to switch my screen. So just copy this question, x squared minus 9 over x minus 3. And when the limit x goes to 3. Okay, and then I want you to go to the GeoGebra app and try to find the value of x at this point, of the function at this point, at x equals 3. And I think you can also share your screen. Let me see. Yeah, let me allow you. I want you to share your screen on your computer so that I can see if you are doing it right or wrong, so I can guide you. Okay. So please do share your screen. Okay, so please do share your
excuse me.
screen. Yep. Yes.
Sir, I'm just a bit confused here because we're plugging values into a computer, but how would we do this on paper?
But no, I asked you to simply copy the question on the paper. You're going to use the GeoGebra to find the value. We're not finding the answer on paper. Yeah, I mean, our aim for this course is to learn the tools or the technology to solve these questions. Okay, of course, I can also explain you how to solve on paper using the algebra, but that will be quite boring and it will take too much time. Yeah, we don't have much time. So we want to exploit, we want to use the tools. Okay. So are you able to get the answer on GeoGebra, by the way? And if you insist doing it on paper, let me give you a hint. You should be using the factorization. So x squared minus 9, that equals x plus 9 times x minus 9, and then you can simplify and then you can find the answer. But that is not our aim. Our aim is to use GeoGebra. All right. So let me just try for you. Let me try again. So first, I can simply define the functions x squared minus 9 over x minus 3. Yep. So, first we define this function. So as you can see here, we have this, let me switch this off. We have this orange curve. And as you can see here, this is a straight line. It's not actually because of the, the overall degree of this polynomial is 1. So it's going to be a straight line. And we want to investigate the limit at point 3. So as you can see here, at point 3, let me zoom in. Yeah, even though it looks simple, but let's try to find the answer at point 3. The thing is that, if you put 3 into this equation, so the 3 square is going to be 9. So 9 minus 9 is 0, and then we have 0 over 0. So apparently, if you use the algebra, it won't make sense, right? It doesn't give you a right answer, or it doesn't give you any answer, because it gives you 0 over 0 form. So how can we fix this idea? So let's try to find the limit. So let's say what is the limiting value of the function at this particular point. So we already have the function up. Sorry. Yeah. So since the function is already defined at point G here, and we want to find the limit at point 3, right? So if you press enter, we get the value of limiting value as 6. So when the value of x goes to 3, the function goes to 6. Actually, it is here. It's not actually quite visible. If I click on this point, it says removable discontinuity. That actually means, there's actually a discontinuity, means the graph is broken at this point. When x equals 3, the graph is somehow broken at that particular point. Can you see the reason why the graph is broken at the point 3? It is because of this denominator, right? If you plug in 3 into this denominator, then we get something over 0. Of course, the numerator is also 0 in this case. But you see from here, something over 0 is infinity. That means the graph should not be behaving quite like in a normal way. But the idea of limit is that we don't care about at that particular point, at the point when x equals 3. What we care is that, once we zoom in to this function, or once we go close to this value of 3, what is the value of the function at that particular point? So that actually, that is the idea of the limit. So as you can see here, if I simply zoom in, there is actually like a kind of hole at this particular point, but we are not interested at that particular point. We are interested mainly what is the value of the function when the value of x goes close to the value of 3. Okay, so this is how we can use the GeoGebra to find the limiting value of a function. So I have some more questions for you, but let's not do it right now. We don't have much time. I'm going to actually put these questions on Google Classroom. So I urge you to try this GeoGebra. And if you have any question, of course, you can also use the platform of Google Classroom and then ask the question. We will try to help each other. Okay. The last thing actually I want you to do is to, I have to change the screen. Yes.
Sir, sorry to interrupt, but I wanted to ask that, is the graph broken at 6?
Yeah, that is actually a very good question. The graph at 6, we don't know if it is broken, or no one knows actually. This is the the problem actually is here is that not at 6, basically at 3, right? You mean 3?
Yes.
So at point 3, the graph, we don't know actually what is happening to the graph. The reason, actually because you have the x minus 3 in the denominator. The thing is that actually if you have a function, let's say 1 over x minus 3, then we know for sure that the graph is broken at point 3. But since in the numerator, x square minus 9, we have the same problem. The graph goes to 0 when you put x equals 3. So then you have actually 0 over 0. So if like something, if you have, let's say 3 over 3, that gives you 1, right? That gives you a unit number. But in this case, since we are dealing with zeros and infinity, it's not actually very, intuitive. We cannot understand. I mean, that is the idea. So we have to deal with the infinity in this way. So the short answer is that no one knows what happens at the point when x equals 3. That is the reason we use the idea of limit. So what limit actually tells you is that the function will be approaching to 6 when you go close to 3. It does not tell you, it cannot tell you what is the value of the function at point 3. Okay, so it can only tell you the approximate value, or it will approach to 6 when x approaches to 3. And actually that is okay, because in our world we don't need the value at that particular point. We can still do all the work just by approximating. So our world is all about approximation, by the way. For example, yeah. Mm-hmm.
So can we say that the value is an asymptote?
Not really, actually. It's going to be asymptote only if you don't have x square minus 9. If you don't have this function on the top, then it will be having an asymptote. Let me actually try to make a function. Let me show you what I mean here. For example, if I make this function only with 1 over x minus 3, let's show you. Actually, if you press on this home button, it will take you to the yeah. So if you have 1 over x minus 3 only, then at x equals 3, there is an asymptote. You see asymptote here, right? But the thing is that since in the function of g of x, we have also in the numerator, we also have the 0, and then once we have the 0 over 0, then it's not the simple case. It's not actually that easy. We have to see which is going to, I mean, maybe I can discuss, but it might take more time. If you're interested, you can also discuss with me. Maybe once the class ends, I can describe to you in detail what is happening here. But the idea is that, once you have only the denominator, which is x minus 3, then you have a asymptote here. But if you also have a numerator, which is also going to 0, which is also approaches to 0, then it's a different story. By the way, we call them indeterminate state. So the answer is there's a particular value. By the way, if you have done the advanced calculus, you have seen L'Hopital rule and many other rules to find those values. But we can simply use the GeoGebra, okay? And we can find the value, okay? All right, so let me quickly share my screen. And the last thing before we say goodbye is this thing. Is that? Yeah. So now actually, I want you to join this group on GeoGebra, and I have assigned you an activity about the slope and about how to use GeoGebra on this group. So you will be working on this thing. And once you master the basic calculations on GeoGebra, we will be doing some more advanced calculation. Okay, Bilal, yeah, I can stay for 5 more minutes. So yeah. Yes, you have, it's not actually required to make an account. You can still join with a simple name, like with any name, but I would recommend you, or I would urge you to make your account, okay? So please do join this geogebra.org/groups and enter this password KS727, and there you will see some tasks about slope and about the interface of GeoGebra, like basic calculations. And I will also be assigning you some more questions about limit and so on. Okay, Bilal, I got your question. So stay with me after the session. I will show you. Okay, guys. So can you please copy this or take the screenshot? I'm going to change my screen. So. Okay, let me actually share the screen. By the way, the time is already up. It's 3:35. So I'm sorry, I'm taking much of your time. So if you want, if you have to go, you can feel free to leave the class. But let me simply show you just a couple of things. So GeoGebra profile. So I want you to join my group on GeoGebra. So if you can also see the. So once you join the GeoGebra, you will see these tasks. So the first one is slippery slope, and this is due, I think, today. Let me change the setting. Yeah, I think it's fine. And there's also 2 more tasks for you about how to explore the app and defining functions and terms and variables and solving equations and inequalities, limit of functions and rational functions and so on. So this is actually not actually like a requirement, but I really urge you to spend and have fun and enjoy this activity. This is really going to help you understand calculus further. Okay. Okay. Yeah. Let me see how many of you have already entered. Nice. So we got Bilal, Hamza, Ibtarik, Mahanur, Abdullah, Raza, Munib, and Nadia. All right, so we're still missing, I think, 1, 2, 3, 4, 5, 6, 7, 8. Yeah, approximately 20% we are still missing. So let me also copy this thing on Zoom. Yes, Mohammed, you can ask your question. Okay, Mohammed, actually, we have some participant from abroad. So that's why I think we should be focused mainly on English. But of course, if you need any extra help, sorry. Yeah, but if you need more clarification, you can ask me in private. I will try to help you in Urdu. Okay, guys, I think it's the time for us to part our ways, at least for 1 week. A couple of things I just want to summarize. Like this session, maybe it might be, you might have realized this is not very well organized or well structured. Again, because this was the first session, I also wanted to know the background of our participant. But I am really positive that you have learned at least something. In the next session, we are going to study mainly the derivative. We will start from limit and then we will do the derivative. But the next session is going to be a bit more technical, and more structured. Okay, so please be well prepared. And of course, after having this activity on this GeoGebra group, you will be more confident using the GeoGebra. So we will be able to use the power of GeoGebra, thank you, in a better way. And meanwhile, I want all of you to join this group, and also the Google Classroom. And the Google Classroom, basically, I think you have the link sent to you on the email. So please do join the classroom. And if you need to ask any question, you can ask on Google Classroom also. Okay. All right. Okay, Navida, no problem. If you are unable to connect now, you can simply write down the password or the link, and you can try to connect later on. Okay, and try to do these activities as quick as possible. Okay. Okay, I thank you all, and I really hope that in the next coming session we are going to have more fun. And please post your questions, whatever comes in your mind. It is I think the fuel for our motivation and for our learning. Okay, thank you very much, and you can leave the Zoom. And I think, who was it? Is Muhammad or